A final decision to go was taken.
10, 9, 8, 7, 6, 5, 4, 3, 2, unité, feu. Allumage. Décollage.
Hello everyone, my name is Christian. Together I want to look with you at 3 different aerospace craft. Once we have a rocket ship, then we have a satellite, but also a plane, like 3 quite different aerospace crafts. And despite of the physical difference, but also in the function and the task they fulfill, they still have one thing in common. All of these 3 aerospace craft, they crashed due to a software mistake, a bug. And the video that you just have seen is one of the aerospace crashes that I want to look with you at. And it's the Ariane 5. So let's get started.
By the early hours of the morning of the 4th of June, Ariane 5 stood proudly on ELA 3, waiting for the final countdown.
It's 1996, 4th of June. We're in South America, the Gonela Space Center. It's the launch day of the rocket ship Ariane 5, and the purpose of the launch was to deliver payloads in space. The rocket ship itself is about 50 meters tall and 5 meters wide. 37 seconds after the launch, the rocket ship crashed mid-air. But before we get to take a look at the actual crash of the rocket ship, I would like to look with you at the inquiry board report, which was released at the 19th of July, just about 2 weeks after the crash. Now, the analysis of the crash shows following insights from the inquiry board report. As the cause of failure, the report points out that the mistake derives from the software engineers. It was explained that Ariane 5 crashed due to an integer overflow error. So further on, the report also explains. The inertial SRI software exception was caused during the data conversion from 64-bit floating point to 16-bit signed integer value. Now the converted floating point value turned out to have much bigger value than what could have been represented by the integer value, and this led to the operand error. So now let's focus on the SRI, because this is where the software bug comes from. The SRI stands for Inertial Reference System. Now, while it might be a little bit confusing because they inverted the initials from IRS to SRI, probably out of convenience it's easier to pronounce SRI, but more importantly, the SRI is a part of the flight control system of the Ariane 5, and its task is to measure the attitude, but also to control the movement of the rocket ship. And exactly this was what happened during the launch of the Ariane 5. Now, if we get back to the video, you can see how rapidly and abrupt the rocket ship just started to move. It was quite a small movement, but the consequences were still pretty high, since it was facing aerodynamic forces, which it couldn't take, like it was simply way too strong. The damage of the crash was approximated at around $370 million. A shocking moment for everyone involved in this scenario, not just the scientists, but also several audience and viewers of the launch itself. But there were no victims and no one was hurt. Now, thinking about that the Ariane 5 rocket ship crashed due to a software bug, it seems very reasonable to blame the software engineers for the mistake, which basically is what the inquiry board report did. Now, a critique from the law illustrates that the mistake, like the root of failure, is to be designated somewhere else. This is Gérard Lallah, a French computer science, and he points out that the conclusion made by the inquiry board is kind of unfair to blame on the software engineers. One aspect of the criticized design was that Ariane 5 reused the SRI system of the previous Ariane 4. This was also mentioned in the inquiry board report, such as the lack of tests. So the reused SRI system wasn't verified in its new environment, and the specifications weren't tested on the Ariane 5 rocket ship. The report also explains that these kinds of tests could have prevented the failure, which is very significant. These were pretty much the main arguments of the law to explain that it's rather the systems engineer's mistake and not the software engineers. That's so far the Ariane 5 incident. Now let's continue with the next aerospace crash, because it is quite similar to the Area 5 failure. It's the 11th of December in 1998, and it was launch day of the Mars Climate Orbiter, launched by NASA. With a size of 2.1 meters and a width of 1.6 meters, the orbiter was quite small, still having a weight of about 638 kilograms. The mission was to study the Martian climate and atmosphere, but also to act as a communication relay. The Mars Climate Orbiter reached Mars for an orbital insertion on the 23rd of September, the same day when the connection to it was lost. The orbiter crashed. So the Mars Climate Orbiter is the next spacecraft that crashed, and one thing it has in common with the Ariane 5 rocket ship is that it happened due to a software mistake. But before I'm gonna explain to you what the software mistake was about, I will first show you in a small animation how the Mars Climate Orbiter crashed in the Martian atmosphere. This is the Mars Climate Orbiter in space. Its intention is to skim through Mars' upper atmosphere. On the attempt to do so, the orbiter crashed instead, because it got closer to the atmosphere than it was intended. Now if we zoom out, you can see the planned trajectory of the orbiter. In comparison to the planned one, the actual trajectory is quite far away, and the reason behind this is the wrong use of metrics. Now, the Mars Climate Orbiter was designed and constructed by NASA together with the help of Lockheed Martin. Lockheed Martin is an aerospace company. So basically we had two different teams working on one big project. For this, NASA set some standards, and one of the standards was to use metric units. And this means while NASA was working with units like meters and Newton, Lockheed Martin instead used the English units. Therefore, they had feet and pound force. Now, the usage, like the wrong usage of two different units, collided in the software, leading to miscalculations during the mission of the Mars Climate Orbiter, and this remained undetected, and that's why it crashed after all. Thinking about that the wrong units were used, this also means there was a software mistake made by Lockheed Martin. But what exactly is Lockheed Martin? Let's briefly check out on Lockheed Martin to get a better understanding of who they are and their contribution to NASA. Lockheed Martin was founded on the 15th of March in 1995 in America, and they are known for their defense and aerospace manufacturing. Back then, Lockheed Martin was formed by the merger Lockheed Corporation and Martin Marietta. This is how the name Lockheed Martin was created. In 1976, Lockheed had a project and contract with NASA and made the first successful Mars lander. His name was Viking Lander. The mission was successful and provided in-depth look at the Martian interior. Now Lockheed Martin operates 4 divisions. Interesting for us is the Lockheed Martin Aeronautics. They were a part of the Mars Climate Orbiter project, which failed. Also here, just like at the Ariane 5 scenario, there is the reason to believe that the root of failure is because of the software from Lockheed Martin. Now in this case, NASA argues that the failure is not to be blamed on the software itself. They start saying, people sometimes make errors. In addition, 2 meaningful characters of NASA, one's the Associate Administrator for Space Science, Edward Weiler, who explains, the problem here was not the error, it was the failure of NASA's systems engineering and the checks and balances in our process to detect the error. That's why we lost the spacecraft. And also the director of solar system exploration, Carl Pilcher agrees with him, saying, "Human error occurs all the time, but even though we have a tremendous success rate because we have systems that detect and correct the errors, the problem here is that our system failed to do that." Now, the similarities I see with the Ariane 5 rocket ship and the Mars Climate Orbiter is that in both scenarios, the software engineers were the one to be blamed for the root of failure. And at this point, my huge respect to NASA, because they are the one to admit on their own that the mistake isn't to be blamed on the software engineers, but instead their own system engineers, to not detect the wrong use of units. But before I will get to talk with you about my final conclusion of the Ariane 5 and the Mars Climate Orbiter, let's continue with the very last aerospace crash. Now, the last aerospace crash that I want to talk with you about is the Boeing 737 MAX plane. And to be more accurate, there has even been 2 crashes of the same plane within 5 months. Now, the first crash was on October 2018 and the second crash on March 2019. The consequences of these crashes weren't just expensive, but especially they were also fatal. 189 people died in the first crash and 157 on the second crash. This makes it a total of 350 people that lost their lives. And before we get to talk about the crash itself, first let's get to know what exactly is Boeing. Boeing Company is an American aerospace industry and is worldwide known for its planes. It was founded in 1916 by William Edward Boeing. Boeing 737-100 had his first flight in April 1967, which was the first 737 variant of this aircraft series. And it has 3 more variants. The first variant started with the Boeing 737 original series in 1968. Followed by 737 Classic in 1984, then 737 Next Generation in 1997, and the last variant is 737 MAX in 2017, which is still active today. The Boeing planes had the best jet engines, and also the aircraft manufacturing is with a value of $180 billion one of the most competitive industries in the markets. That's A320, a plane of Airbus SE, another competitor of the aircraft market. For a long time, Boeing was by far the best aircraft industry, but it changed for a while. Let's look at this graph. It visualizes the number of aircrafts that were delivered each year. We have the 737 family of Boeing and the A320 family of Airbus. In the last few decades, the delivered aircraft spiked high for both aircraft families. That's also the time when the new 737 MAX series was introduced in 2017, and very soon also when the first 737 MAX plane crashed. The first 737 MAX crash in October 2018 was a big scandal and caused a huge uproar. Not just in the news and among the affected ones, but also among the pilots. Turns out that several pilots have already reported their concerns, some of them also before the first plane crash even happened. It was also reported that other pilots had struggled successfully against the new erroneous systems of the 737 MAX. So let's dive into the problem of the 737 MAX. The new design of this plane required an anti-stall mechanism to counter the new problem the design carried on. For this, Boeing introduced MCAS, which stands for Maneuvering Characteristics Augmentation System. Basically, it uses a vane sensor to measure the angle of attack, short AOA. I will not explain in detail what the angle of attack is, but with a too high or too low angle of attack, the plane is in danger to stall and therefore to crash. In theory, the MCAS is very important, but in the implementation it had a quite huge flaw. It only used one single AOA sensor, even though the plane had 2 of them. Now the problem with using only one is, it can become malfunction and measures wrong values. That's why it's bad practice to only use one single point of sensors. Now, one big problem is that the MCAS systems of the planes tended to be erroneous or malfunctional. Now, the other big problem is many pilots haven't been taught how to use MCAS at all. Some of them even reported that they didn't even know about the existence of MCAS. And that's because Boeing decided to not include the MCAS system into the retraining course of the pilots. And the reason behind is, after all, Boeing got dominated by the sales and marketing, and that's how they ended up prioritizing sales and marketing over the safety of the planes and also the proper engineering. Okay, hi, welcome to the conclusion, which is also pretty much the end of the video. Now, the Boeing 737 incidents are, in my opinion, the most complex crashes compared to the other two incidents in this video. There are many parameters of why the planes crashed, and I think it's difficult to explain where exactly the problem was. The MCAS software did make a huge mistake in the implementation. It was poorly designed, but at the same time the entire development of the plane shows many complexities at all. I can't even entirely say where the blame is to be put, and I think I will try to distance myself from giving a conclusion on that aspect. But for sure it is very shocking once you get to understand that the plane didn't necessarily just crash due to technical issues, but also on the education of the pilots and decision makings of the plane itself, considering the manufacturing and the safety of everyone involved in this scenario. Getting back to Ariane 5, also here it was very interesting to see the depths of the design. The software error seems quite banal, but it still had incredibly high consequences with the crash of the rocket ship, and pretty much the same applies to the Mars Climate Orbiter. In my opinion, these mistakes seem quite simple, an integer overflow error and the mixed use of units. But at the same time I know that these mistakes happen, either to myself, but for sure also among the best software developers. So while I was first shocked to see what software mistakes were made in big and expensive projects, very soon I could totally understand and agree that the lack of tests was rather an issue instead of the software mistakes themselves. And at the same time again, especially as a normal computer science student, I can imagine that the debugging of my regular implementations aren't even as complicated as making proper tests on an entire rocket ship, satellite or plane. That's at least my opinion. Now, ladies and gentlemen, that's about it. Bugs in aerospace, the failure and cause. I hope you enjoyed this video. Have a blessed day. Goodbye, everyone.